Yeah, dear students, everyone, good afternoon. This is Bashir, Math faculty from Infinity Learn by Sri Chaitanya. Right, dear students, in today's session, I'll try to brief the complete chapter of permutations and combinations in a quick way. Okay, dear students. Yeah, first of all, permutation combinations topic, it starts with fundamental principle of counting. You see, fundamental counting principle of multiplication, addition, then we'll focus on linear permutations and permutations of n dissimilar things, permutations when repetitions are allowed, as well we have seen permutations when certain things are alike. These models first we will focus, dear students. So, first I'll try to cover all the models related to permutations, then we will go to combinations. Right. So, I will try to see that all the main models will come into discussion in the coming 90 minutes. Just please be keen and try to answer the questions. Yeah. You see, dear students, what is a permutation? You know well, before a permutation, I want to recall fundamental theorem of, fundamental counting principle of addition as well as multiplication. Suppose, friend, there are two works. First work can be done in m ways, second work can be done in n ways. Now, if I want to do both the works one after the other, the number of ways that we can do is m into n ways, first work and second work, right? Suppose that means the works will be like ordered pairs. Suppose if you want to do first work or second work, that means you will be doing either this or that. Total number of ways will be m plus n ways. This is the second basic point. With the help of these 2 points, we develop the total chapter. Right, dear students? Yeah, good evening, Bharadwaj. Yes. Second point, my dear friends, after this, so trying to solve the problems with the help of boxes. Suppose, my dear friends, there are 6 students, there are 3 chairs. In how many ways these 3 chairs can be, the students can be arranged in these chairs? You see, first place can be filled in, hello, speed booster, hello, first place can be filled in 6 ways, second, so one place is filled, 5 students are left. So, second place can be filled in 5 ways. Now, we are left with 4 students and 1 place. This place can be filled in 4 ways. So, by the fundamental counting principle of multiplication, so total number of ways will be 6 into 5 into 4, my dear friends. Mathematically, we write symbolically 6p3, right, dear students. So, in fact, we can also multiply and divide this with 3 factorial. So, this becomes 6 factorial by 6 minus 3 factorial. So, dear students, I tried to give 2 fundamental points with the help of which we develop the total theory. Okay, right. Here, coming to the point, first point, my dear friends, the number of linear arrangement that can be formed by taking r things at a time from a set of n dissimilar things is denoted by NPR. So, a point में एक point लेना है आपको. We have 10 students, 4 chairs. In how many ways we can arrange is the first point. If you don't understand whatever I have discussed earlier, no issue. 10 students, 4 places. In how many ways we can arrange? The answer is simple, 10p4. This means how to compute? 10 into 9 into 8 into 7. This is simply starting from 10, you just multiply 4 numbers to the back. That's it, my dear friends. Suppose there are 4 students, I have to arrange in 4 places. That means if you are taking all the 4, this becomes 4p4, which is nothing but 4 factorial. That is simple. This is concept number 1. Okay. Suppose there are 10 boys, we have to arrange 6 of them in a row. The answer is 10p6, the number of ways. If you want to arrange all the 10 members in a row, 10 factorial is the answer because 10p10. This is point number 2, my dear friends. So, NPR you know. Next concept, you see the number of ways of selecting or things at a time from a set of n dissimilar things. You see, earlier one is number of ways of arranging. Permute means arrange, combination means selection. Suppose there are 5 students, say A, B, C, D, E. You want to select 2 students, symbolically it is written 5C2. C stands for combination, number of selections. The answer would be, my dear friends, 5 into 4 is 5p2, right? Number of arrangements by 2 factorial. You write. That's it. For example, you want to compute 10C3. Starting with 10, you multiply 3 numbers to the back, which is 10p3 by 3 factorial. That's all. You know how to compute NCR. If I want to write the formula, NCR is nothing but NPR by R factorial. I am not going to derive all these things because it is a quick revision. This is nothing but, my dear friends, n factorial by n minus r factorial into r factorial. But we just compute with the help of these formulae, dear students. ऐसा कंप्यूट करना है. अगर हमें 20C4 कंप्यूट करना है तो 20, 19, 18, 17 4 नंबर्स बैक मल्टीप्लाई कीजिए बाई 4 फैक्टोरियल. ऐसा कंप्यूट करना पड़ेगा. सो डियर स्टूडेंट्स, so this point is, suppose let me say 10 students are there. I want to arrange 4 of them in a row. The answer is 10p4. I want to select 4 students. The number of ways is 10c4. If I want to arrange all the 10 students in a row, the number of ways is 10p10, which is nothing but 10 factorial. If I want to select all the 10, select in the sense 10c10, which is going to be 1, my dear friends. Selecting all the students is only one way, right? With these fundamental points, we shall enter the problem. Before that, sometimes in certain exams we are getting questions on factorial also. The remainder obtained when 1 factorial to 49 factorial, the sum is divided by 20, my dear friends. So, ये देखिए 1 factorial 1 होता है, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, whereas 5 factorial is 120, because 5 factorial क्या होता है, this is 1 into 2 into 3 into 4 into 5, which is already multiple of 20. So 6 factorial is this into 6. So from 6 factorial, 7 factorial, 8 factorial, all are multiples of 20. So my dear friends, I can write this sum as 1 plus 2 factorial 2 plus 3 factorial 6 plus 4 factorial 24 plus rest of all are multiple of 20 only. From 5 factorial to, you can say whatever factorial you take, each factorial is a multiple of 20. So now you just add these 33 plus 20 multiple. Here also you can separate 13 plus 20 plus 20k. Up to here it is divisible by 20 and hence the remainder is going to be 13, my dear friends. So in certain exams, like you see NDA exam is there on September 3rd. So you can expect this kind of questions we have also seen, dear students. Okay. Next, ये देखिए, you see permutation based questions. The number of 4-digit odd numbers that can be formed with these digits. You see, generally permutation means we can, can you repeat the concept once? Which concept? Ronak, the previous one? Okay, the question is, Ronak, the remainder when the sum is divided by 20. So I am going to divide the total sum with 20. My point is very simple. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 20, 5 factorial, my dear friends, 5 factorial is going to be, okay, yeah, 5 factorial is 120. From 5 factorial, all the upcoming factorials are multiples of 20, and hence, my dear friends, I have written rest of the sum as 20k. This is altogether 33, which I can write like 20 plus 13, and hence this is divisible by 20. So 13 is the left out number. So 13 is the answer. The next, dear students, the number of 4-digit odd numbers. Such questions can easily be answered with the help of, with the help of box logic. I want to form a 4-digit odd number, so put 4 boxes. Odd number means, you see, 1, 3, 5, 7, 9. There are 5 odd numbers, so the last place must be filled with one of the digits, dear students. There are 5 digits, so this can be filled in 5 ways, okay, that can be formed, right. After that, my dear friends, you are left with 1 digit is filled here, you are left with 8 digits. These 8 digits, this place can be filled in 8 ways, here 7 ways, here 6 ways. So the answer is 8 into 7 into 6 into 5, my dear friends. Very simple it is, okay. Yeah. Okay, right, dear students. Next. So whenever you are given problem on NPR, dear students, so please remember there will be 4 important models. Model number 1, my dear friends, n things are to be arranged in a line. Whenever you are using NPR for a permutation, do remember the arrangement repetitions are not allowed. For example, you see how many 4-digit numbers can be formed with 1, 2, 3, 4 means there will be two ideas will come. Can the letters be repeated or not? If repeated, the answer would be 4 into 4 into 4 into 4. If repetitions are not allowed, the answer will be 4 into 3 into 2 into 1. So this is why if you are using NPR for arrangement, do remember repetitions are not allowed. Repetitions are not allowed. Second thing, you see, all the n things are dissimilar. That means, friends, suppose A, B, C, D are the 4 things dissimilar, the answer you can write. Suppose there is like A, B, C, D, there are certain things similar, then you cannot, so you cannot write NPR directly. So friends, all the n things must be dissimilar, dissimilar, dissimilar. Next, third point, my dear friends, do remember you are arranging in a row, my dear friends. You are arranging in a row. If not row, what is the other way? Suppose if you arrange in a circle, number of arrangements will vary, my dear friends. So for arrangements, please, it's very, very important point, listen to me. For arrangements, if you are writing NPR, that means 3 things you have to ensure. The arrangement is being done in a line. Second thing, repetitions are not allowed. Third thing, all the things are dissimilar. Now the question is, now the question is, dear students, if repetitions are allowed, how to handle? Second, if certain things are similar, how to handle? If it is not row, if it is a circle, how to handle? Right, dear students. You see, first question, when repetitions are allowed, you just see the number of 4-digit numbers. Listen to me, very simple. That can be formed with 1, 2, 3, 4, 5, 6 when repetitions are allowed. So, my dear friends, the number is 1, 2, 3, 4, 5, 6. 6 digits are available. Repetitions are allowed. I want a 4-digit number. So the first place can be filled with any of the 6 digits. Yes. So even the second also, because the same digit can also be repeated. Even the third also, even the fourth also. So the answer is, my dear friends, 6 power 4. Do remember. Okay. When repetitions are allowed, box logic, or this generally we call it as box logic. Put boxes and fill the ways. That is the easiest method, conceptual one. The next, my dear friends, the number of 4-digit numbers that can be formed with 1, 2, 3, 4, 5, 6 that are divisible by 3 when repetitions are allowed, my dear friends. Here, dear students, divisible by 3 in the sense, you just see, my dear friends, luckily here divisibility rule for 3 is sum of the digit must be divisible by 3. Out of the 6 digits, you can say 1 and 4 are of kind 3k plus 1, 2 and 5 are of kind 3k plus 2, 3 and 6 are of kind 3k. So all are equal in number. So you just take total possible 4-digit numbers with these. So this can be filled in 6 ways, 6 ways, 6 ways, 6 ways. 6 power 4 will be the total number. Undoubtedly, for each possibility 3k plus 1, 3k plus 2, 3k plus 3, you are getting equal possibilities. Out of these, 1/3 will be of multiple of 3 and 1/3 will be 3k plus 1 type, 1/3 will be 3k plus 2 type. So the answer is 6 power 4 by 3, my dear friends. Okay. Yeah, not required, Ronak. Simple, close. Because you see, there are 6 numbers. For each of these, we are having equal chance. Undoubtedly, out of these, 1/3. You see, the question is how many 4-digit numbers can be formed with these digits which are divisible by 3. I am saying, so of the given 6 digits, there are two numbers of 3k plus 1 type, 2 numbers of 3k plus 2 type, 2 numbers of 3k type. Okay. So my point is, if you just form all the 4-digit numbers, 6 power 4 numbers will be. Of these, my dear friends, yeah, Tripathi, of these, since all are of equiprobable, you will definitely get 1/3 of 3k type and another 1/3 of 3k plus 1 type, another 1/3 of 3k plus 2 type. So I just want multiple of 3, yeah, you will get 1/3 of this. That's all. I don't divide into cases, right? Okay, right, dear students. Then the number of positive integers having at most 20 digits using the digits 1, 2, 3, 4, 5, 6. At most, you see, positive integers having at most 20 digits. That means with these 6 digits, you can form a single digit number, 2 digits, 3 digits. Single digit numbers will be 6, my dear friends. 2-digit numbers will be, you see, you can, when repetitions are allowed, indirectly he has given that repetitions are allowed. Otherwise, how can you get up to 20 digits, right? 6 square. 3-digit numbers will be 6 cube, like that. 20 digits number will be 6 power 20. So all such numbers could get like 6 plus 6 square plus 6 cube plus and so on, 6 power 20, which is a GP with first term 6, common ratio 6, number of terms 20. So A into r to the power of n minus 1 by r minus 1 is the answer. You can leave like this. You can simplify if you want. Of course, 6 power 20 is a very big number. Okay. So this way you can do, dear students. Next, you see the number of positive integers having at most 10 digits using the digits 0, 1, 2, 3, 4, 5, 6, 7, in which 0 is also there. Please do remember. Just observe the difference from model to model. You see the number having at most 10 digits, yeah, Tripathi, I will tell 99 percentile in JEE mains is very simple. You see, to get 99 percentile, very simple technique, you have to score, you see, 80 plus in physics, 75 plus in chemistry, 60 plus in math with respect to the last 3-4 years all the JEE mains. Okay. So, dear students, in this math you need to select 15 important chapters and practice those. You must be very strong in half of the syllabus, and rest of the half, if you are comfortable with the basic models also, it is very easy to get, it's very easy to get, I mean to say 99 percentile in math, for which you require just 50 to 60 marks, right. Coming to the point, number of positive integers having at most 10 digits using these digits. So, repetitions are allowed. So, how many single digit numbers can be formed? 7 only, but not 0. How many 2 digit numbers can be formed, my dear friends? When 0 is there, you can do like, so first place can be filled in 7 ways, second place can be filled in 8 ways. So, 7 into 8, my dear friends, or else you can also write 8 into 8, 8 square, minus of those the numbers which start with 0 is 0 into 8, 8 square minus 8. Okay. This is also fine. How many 3 digit numbers can be formed where 0 is there? You just form all the 3, 8 cube will come. Of those you subtract which start with 0, because they are not 3 digit numbers. If you put 0, you will get 8 square. So, like that, at most 10 digit means 8 power 10 minus 8 power 9 will come. This also you can write 8 minus 1. If you just add all these, my dear friends, these two get cancelled like this. Finally, you will get 8 power 10 minus 1 is the answer, right, dear students. So, 8 power 10, that means you take 10 digits, you can fill with, you see, a simple technique is, you want a 10 digit number, like that you can put 5, 6, 7, 8, 9, 10. You write all the possibilities, you will get 8 power 10. Of these, remove one digit where all are filled with 0. The rest of you will be getting single digit, double digit, 3 digits, everything you will get. Okay. Yeah. Next, my dear friends, the number of ways of, you see, this is a good question, important question. The number of ways of wearing 6 different rings to 5 fingers. You see, students will be thinking 5 power 6 or 6 power 5, one confusion will be there. The point is, my dear friends, number of ways of wearing rings to fingers. You see, that means at the end of the problem, every ring will go to some finger. So, ring number 1 can be given to any of the 5 fingers, ring number 2 also, 3 also, 4 also, 5 also, 6 also. 5 power 6 is the answer. If somebody says why not 6 power 5, so first finger can receive any of the 6 rings, second finger, but here, my dear friends, this analogy is wrong, because if finger number 1 may or may not receive some ring. So, this is why always think from rings to fingers, not from fingers to rings. It is very, very important. In that case, you will get 5 power 6. Okay, dear students. Okay. Yeah. Next, my dear friends, you see the number of, when similar objects are present, my dear friends, the number of permutations that can be made by taking all the letters of the word target. My dear friends, suppose your word is clear, in which all the 5 letters are dissimilar, the total number of arrangements are just 5 factorial. You know, I am not going to discuss the proofs and all. Here, suppose I need to arrange all the letters of the word target, in which there are 2 T's are there. So, the answer will be total 6 factorial, but there are 2 similarities. So, I can write by 2 factorial. Next, my dear friends, in the same way, mathematics is another word. You see, 3, you can say 6, 9, 11 letters are there, of which there are 2 M's, 2 A's, 2 T's. So, 2 factorial into 2 factorial into 2 factorial, and remaining are distinct. Okay, yeah, right, my dear friends. Similarly, Mississippi is another such kind. You see, if all are dissimilar, simply direct factorial. If there are certain similarities like Mississippi, you see, M-I, S-S-I, S-S-I, P-P-I. So, that means out of 11 letters, so 11 factorial, 4 I's, 4 S, 2 P's, my dear friends. In these many ways we can arrange, my dear friends. Okay, right. So, the number of permutations that can be made by taking exactly 4 letters of the word mathematics, it's a beautiful question. You see, my dear friends, in the earlier case, as I told you, as number of arrangements formula NPR is allowed when all the n things are dissimilar and repetitions are not allowed and we are arranging in a row. The case 1 we have seen, if repetitions are allowed, how to handle we have seen. The second case is, if certain things are similar, how to handle we have seen. Here we are taking all, target means we are taking all the 6, whereas in this problem also we are going to arrange where certain things are similar, but we are not taking all, we are taking only few. You see, the number of permutations that can be made by taking exactly 4 letters of the word mathematics. So, exactly 4 letters in the sense M, A, T, H, E, M, A, T, I, C, S. So, you can see here in this word there are 2 M's, 2 A's, 2 T's, my dear friends. So, 6 plus 5, there are 11 letters, right. Now, I can say, dear students, so you have to think all the 4 can be distinct, like different kind of. All the 4 different means how many? 1, 2, 3, 4, 5, 6, 7, 8 letters are there. Out of 8, you select 4 and arrange them. 8C4 into 2 factorial. There may be other case like 2 same, 2 different. 2 same means it can be MM or AA or TT. Out of these 3 you select one. Once suppose MM is selected, you are left with 1, 2, 3, 4, 5, 6, 7 different letters. From the 7 you select 2. So, now you have selected 4 or which 2 same, you can arrange like 4 factorial by 2 factorial. The other combination is, my dear friends, 2 same combination. Out of, that means 2 same, out of these 3 pairs you select 2, my dear friends. Now you got 4 of which 2 same are there. So, you can just write 4 factorial by 2 factorial into 2 factorial, right, dear students. So, the number of ways of arranging certain things, we are not taking all, only few we are taking and selecting. When things are similar, you just take the different combination, first you select, then arrange, my dear friends. Okay, right, dear students, fine. Next, so in this way, you see, we have recalled fundamental counting principle of multiplication, fundamental counting principle of addition, and linear permutation, simply NPR. In this, there are certain limitations. If there are certain similar things are there, how to handle, just now we have seen. If repetitions are allowed, how to handle, we have seen. When certain things are alike also, we have seen. Okay, right, my dear friends. Now we have to see, if you are arranging in a circular, how to do. Then hanging circular arrangements, there is a slight difference between these two. Then questions on divisibility, questions on sum, rank of a word, palindrome, specific order, derangements, number of functions. These many models are left in permutations. Dear students, do remember permutations, combinations, when you take 2, permutations models wise very big concept wise, and combinations is very small, only 2 points, but more applications will be for combinations. Of course, permutations also, but when compared to permutations with respect to JEE exam, combinations application will be more in number. So, dear students, anyhow, in permutations we have done half of this so far, then we can see combinations part. Simply, my dear friends, the number of 4 divisibility problems are given here. Before that, my dear friends, let me recall circular permutation related. Suppose if I want to arrange, there are n dissimilar objects of which if you want to arrange r objects in a row is NPR, you know. Suppose if you want to arrange in a circle, the answer is going to be NPR by R, NPR by R. Suppose if you are taking all, my dear friends, this is going to be NPN by N, which becomes N minus 1 factorial. 2 points, my dear friends, related to circular arrangement. Okay. The next, dear students, here the number of 4-digit numbers that can be formed with, you see, this divisible by 3 when repetitions are allowed. We have already seen this question, already total number of 4 digits we have done, and we've, so you see, dear students, sum we have to talk, because the previous case here number we have already seen. You see, you got 6 power 4, 1/3 will be divisible by 3. We have concluded this problem. Now the point is sum of all 4-digit numbers that can be formed with 1, 2, 3, 4, 5. So how to do this question, my dear friends? Our digits are 1, 2, 3, 4, 5. I want to form 4-digit numbers. Actually 5p4 will come, almost it is 120. I have to find sum of all those. Then you can do one thing, my dear friends. You see, you want to form a 4-digit number, so select one of the digits. So how many numbers will be there where, 1 is in units place? There will be, my dear friends, out of 4, 3 places are there, 4 digits are left. You can write 4p3. In these numbers, 1 is in unit place. So into 1 you write. So 1 is in tens place will be 4p3 numbers where you will get the value as 10. And 1 is in 100 place, you can write 4p3 into 100, and 1 is in 1000 place, 4p3 into 1000. So what is the sum because of 1? It is 4p3 into 4 ones, my dear friends. Similarly, what is the sum due to 2? 4p3 into 220, because it is 220, 200, 2000. So in the same way, what is the sum due to 5? It is 5, 5, 5, 5. Sum of all these, my dear friends, you will get 4p3 into, take 4 ones into sum of all the digits, 1 plus 2 plus 3 plus 4 plus 5. So my dear friends, I mean to say, so here if there are n digits are given in which 0 is not there, so I want r digited number, this becomes n minus 1 p r minus 1 into, you will get 1 1 1 r times into sum of the digits, sum of digits. This is the shortcut, my dear friends. You can adopt this shortcut, you can adopt this shortcut to find the sum of these digits easily. Okay, right? Next, my dear friends, the sum of all the 4-digit numbers that can be formed with 0, 2, 3, 5. This is like, my dear friends, in the, you can do by concept, or you can also do like, so how many ways, like in earlier case, I am given 0, 2, 3, 5, 4 digits. I want sum of all 4-digit numbers. By previous shortcut, you see, n minus 1 c p r minus 1, this is 4 digits are there, p, that is 3p3 you will get, my dear friends, into 4 ones into sum of the digit 0 plus 2 plus 3 plus 5. There are certain numbers where, हिंदी में क्या करना है मैं बता रहा हूँ, यूवी ये क्या है, सम ऑफ 4-digit नंबर्स होना है 0, 2, 3, 5 यूज करके. यहाँ प्रीवियस प्रॉब्लम में मैं एक शॉर्टकट बताया, 4 डिजिट्स दिए गए हैं, 4 डिजिट्स वाला नंबर का सम फाइंड आउट करना है. तो क्या करते हैं, n-1 c r-1, यहाँ पे 4 डिजिट दिए गए हैं, n वैल्यू 4 है, मुझे 4 डिजिट्स का सम चाहिए, r वैल्यू भी 4 है। n-1 c r p r-1 लिखते हैं, 4 वंस होते हैं, सम ऑफ ऑल डिजिट। इसमें से जहां पे 0 होता है, फर्स्ट डिजिट 0 होता है, वैसे 4 डिजिट नंबर नहीं बोलते, 4 डिजिट वो नंबर का सम हमें रिमूव करना पड़ेगा। सो अगर 0 नहीं है तो 3 डिजिट नंबर सम क्या होता है, हमें 3 डिजिट्स और ये 2p2 और 3 वंस इंटू सम ऑफ द डिजिट्स 2 + 3 + 5 होता है। ये शॉर्टकट हमें सम फाइंड आउट करने के लिए इजी से हम अप्लाई कर सकते हैं। ओके बच्चों, सो इसके बाद ये देखिए, all the numbers that can be formed using the digits 1 2 3 5 are arranged in descending order of magnitude, then the rank of the word, rank related problem चाहिए। rank माने ये numbers को हम descending order में arrange कर रहे हैं, चाहे ये 1 2 3 4 5 को हम लेते हैं, 5 फर्स्ट नंबर है, 4 सेकेंड नंबर है, 3 सेकेंड, देन 2 1। सो ए नंबर का रैंक फाइंड आउट करना पड़ेगा। सो हमें कैसा फाइंड आउट करते हैं, 5 से स्टार्ट होने वाले नंबर्स कितने होते हैं, अगर 5 फिक्स करते हैं तो 4 फैक्टोरियल होते हैं 24। इसके बाद यहाँ पे नेक्स्ट हम 4 से स्टार्ट होने वाले नंबर्स के लिए वेट करते हैं, ऐसे नंबर 4 फैक्टोरियल होते हैं। इसके बाद 3, हमें 3 चाहिए क्योंकि हम 3 से स्टार्ट होने वाले नंबर्स पूरा नहीं लेते, इनके बीच में ही ये नंबर आता है, इसलिए 3 लेते हैं। 3 के बाद क्या होता है, 3 5 से स्टार्ट होने वाले नंबर्स 3 फैक्टोरियल होते हैं। बाद में 3 4 तो चाहिए, सो माने 3 4 के बाद ये 3 हो गया, 3 4 भी चाहिए। इसके बाद 3 4 5 से स्टार्ट होने वाले 2 फैक्टोरियल होते हैं। 3 4 5 होने के बाद 3 4 2 तो चाहिए, सो 2 कैंसिल करो। इसके बाद 5 से स्टार्ट होने वाला नंबर चाहिए, ये 1 फैक्टोरियल होता है। इसके बाद 3 4 2 5 के बाद क्या होता है, 1 5, ए नंबर तो चाहिए। रैंक चाहिए माने इसे भी काउंट करना पड़ेगा। अब देखिए 4 फैक्टोरियल इज 24 24 6 2 1 1। देखिए 48 50 58 होता है, ये नंबर का रैंक 58 होता है। ये प्रॉब्लम में देखिए कंफ्यूजन होने का कुछ भी जरूरत नहीं। अगर नंबर हमें इसका रैंक क्या है, डिसेंडिंग ऑर्डर में अरेंज करना है तो डिजिट्स को डिसेंडिंग ऑर्डर में लीजिए, ये नंबर का रैंक कितना होता है फाइंड आउट कर सकते हैं। ओके बच्चों, इसके बाद ये क्या है, नंबर ऑफ 5 डिजिट इवन पैलिंड्रोम्स चाहिए हमें। पैलिंड्रोम्स माने शायद आप जानते हैं, या पैलिंड्रोम्स माने अगर लाइक ए नंबर बोलता है ABCD CBA, ये नंबर देखिए हम लेफ्ट से राइट और राइट से लेफ्ट किधर से भी पढ़ते हैं तो सेम नंबर आता है, ऐसे नंबर को मैथमेटिक्स में पैलिंड्रोम बोलते हैं। 5 डिजिट इवन पैलिंड्रोम चाहिए। सो देखिए 5 डिजिट इवन पैलिंड्रोम माने अगर आपको इवन चाहिए तो यहाँ पे कौन सा डिजिट से फिल करना है, 2 4 6 8 0। मगर हम यहाँ पे 0 रखते हैं तो यहाँ पे 0 रखना पड़ेगा क्योंकि फर्स्ट और लास्ट डिजिट सेम होना चाहिए। सो इसलिए 0 तो फिल नहीं कर सकते, यहाँ पे 4 वेज फिल कर सकते हैं। ओके, यहाँ पे जो डिजिट फिल हुआ है वही डिजिट यहाँ पे लिखते हैं, सो इसके लिए ओनली 1 वे होता है। इसके बाद यहाँ पे फिल करो, 1 डिजिट तो हो गया, ऑफ कोर्स रिपीटिशन से लोड, यहाँ पे 9 वेज में फिल कर सकते हैं। सो यहाँ पे 10 वेज में फिल कर सकते हैं, या सो ये डिजिट तो सेम यहाँ पे जो होता है वही कॉपी कर सकते हैं, राइट। ये देखिए नंबर ऑफ 5 डिजिट इवन पैलिंड्रोम्स, इसे कैसा फिल करना है, या इसे कैसा फिल करना है, ये देखिए 5 डिजिट इवन पैलिंड्रोम माने 5 डिजिट नंबर लिखते हैं। यहाँ पे बिना 0 हमें इवन चाहिए, सो यहाँ पे 2 और 4 और 6 और 8 4 वेज फिल कर सकते हैं। सो सेम यहाँ पे कॉपी कर सकते हैं। इसके बाद यहाँ का डिजिट हम एक्चुअली किसी भी डिजिट लिख सकते हैं, 10 वेज, ये भी 10 वेज एक्चुअली। सो दिस विल हैव ओनली वन वे, क्योंकि यही कॉपी करना पड़ेगा. दिस इज ओनली वन वे, क्योंकि यही कॉपी करना पड़ेगा. ओके, इसलिए आवर आंसर इज गोइंग टू बी 400 बच्चों. 400 इज द आंसर. ओके, ये देखिए, ये क्या है? स्पेसिफाइड ऑर्डर माने क्या है? ABC are 3 persons among 7 persons who speak at a function. The number of ways in which they can be done, A speaks before B, B speaks before C. ये देखिए, ये 7 students हैं. These 7 students are to be arranged in a particular order. Actual arrangement is 7 factorial. लेकिन यहाँ पे क्या है? So A less than B less than C in the sense, ये it doesn't mean that B comes just immediately after A. So A के बाद some PQ हो सकते हैं, बाद में B आना चाहिए, उसके बाद some L आ सकता है, then C लिख सकते हैं. But A less than B less than C, अगर किसी को specified order restrict करते हैं तो इसका वैल्यू क्या करते हैं? रेगुलर अरेंजमेंट बाई 3 फैक्टोरियल होता है इसका. सो 7 फैक्टोरियल बाई 3 फैक्टोरियल जो आंसर होता है वही आंसर लिख सकते हैं. ये 5040 है, अराउंड 800 में आता है. दिस इज 5040 डिवाइडेड बाई दिस. ओके, राइट. नेक्स्ट 3 फैक्टोरियल इज 3 इंटू 2 6 होता है. नेक्स्ट डियर स्टूडेंट्स, ये देखिए डीरेंजमेंट्स. डीरेंजमेंट्स माने क्या है? प्रिंसिपल ऑफ इंक्लूजन एक्सक्लूजन के हेल्प से हम इसे डिराइव करते हैं. माने अगर देर आर n लेटर्स, so you need to attend round 2 also, Shivam. Okay, you need to attend for the score exam along with round 1. You need to attend the interview also. So round 2 kind of. Okay, right dear students. Yeah, यहाँ पे देखिए, you see if there are n different letters, suppose my dear friends 5 letters है A B C D E. ये 5 letters, इसका corresponding addressed envelopes A B C D E है. ये 5 letters को 5 envelopes में place करना पड़ेगा. Generally 5 factorial ways place कर सकते हैं. इसमें से point ये है कि so there can be many combinations where only few letters go into right envelope or no letter goes into right envelope. For example, ये covers A B C D E में, suppose मैं यहाँ पे B C D E ये fill करता है. देखिए no letter went into right envelope. So I want such kind of arrangements where no letter goes into envelope, right envelope. इसे बोलते हैं, क्या बोलते हैं इसे? राइट, डीरेंजमेंट्स बोलते हैं. विद द हेल्प ऑफ प्रिंसिपल ऑफ इंक्लूजन एंड एक्सक्लूजन, D5 क्या लिख सकते हैं? 5 फैक्टोरियल इंटू 1/2 फैक्टोरियल माइनस 1/3 फैक्टोरियल प्लस 1/4 फैक्टोरियल माइनस 1/5 फैक्टोरियल लिख सकते हैं. सो यू सी 5 फैक्टोरियल बाई 2 फैक्टोरियल, दिस इज 60 minus 20 plus 5 minus 1. So friends, 44 is the answer. ऐसा लिख सकते हैं. इसे derangements बोलते हैं बच्चों. Right? You see, the number of ways of 5 different letters can be placed in 5 addressed envelopes so that one letter is in right envelope and all the remaining are placed in wrong envelopes. So one letter is in right envelope. So when all went wrong, one correct, is it possible? So you see, you can say like A, B, C, D, E. That means you have to put exactly, you see he is saying that so that one letter is in right envelope. So A, B, C, D, E, suppose, so A में भेजते हैं, हमारे पास B, C, D, E, you have to arrange like C, D, E, B. That means one will go into right envelope. So which one out of 5 you select one, that will be kept into right envelope. Remaining 4 you can write like D4, my dear friends. Derangements with 4. Okay? Yeah, ये simple है. So अगर आपको 2 letters right envelope में जाना है, which 2 he didn't specify. So 5 में से 2 select कीजिए, 5 C2 ways. वो दो करेक्ट परफेक्ट अरेंज कीजिए, सो ओनली वन वे। इसके बाद रिमेनिंग 3 के लिए D3 लिखना पड़ेगा। ओके, राइट डियर स्टूडेंट्स। नेक्स्ट क्या है, नंबर ऑफ फंक्शंस। नंबर ऑफ फंक्शंस आप जानते हैं, अगर फर्स्ट सेट A में m एलिमेंट्स है, सेकेंड सेट B में n एलिमेंट्स है, टोटल नंबर ऑफ फंक्शंस विल बी n पावर m एंड नंबर ऑफ वन फंक्शन क्या होता है, npm होता है, where n will be greater than or equal to m, and many one functions means total number of functions minus one functions होते हैं। नेक्स्ट डियर स्टूडेंट्स, इसके बाद क्या है, ये क्या है, टोटल नंबर ऑफ फंक्शंस, वन फंक्शंस, मेनी वन फंक्शंस, वन मेनी वन, या देन ऑन टू फंक्शंस देखिए, नंबर ऑफ ऑन टू फंक्शंस। सो अगर m n है, n पावर m माइनस nc1 इंटू n माइनस 1 पावर m प्लस nc2 इंटू n माइनस 2 पावर m माइनस nc3 इंटू n माइनस 3 पावर m, ऐसा दिस विल क्लोज एट वन पर्टिकुलर स्टेप। सो नंबर ऑफ फंक्शंस ऐसे लिख सकते हैं, इसके रिलेवेंट प्रॉब्लम्स यहाँ पे दिए गए हैं बच्चों। सो एक क्वेश्चन आप आराम से आंसर कर सकते हैं, नंबर ऑफ फंक्शंस फ्रॉम सेट ए कंटेनिंग 5 एलिमेंट्स एंड बी कंटेन्स 4 एलिमेंट्स, नंबर ऑफ फंक्शंस n ऑफ b पावर n ऑफ a, 2 पावर 10 which is 4 पावर 5 is the answer. Number of functions from set a to a set b, so n of b power n of a, right? इसके बाद the number of many one functions from set 1 2 3 to 1 2 3 4. You see many one functions माने total number of functions 4 cube minus one functions will be 4p3 my dear friends. That's it, a simple है। इसके बाद number of onto functions, especially when n of b is having 2 elements, so total number of functions 2 power 5, इसमें से 2 functions हम subtract कर सकते। वो कौन से है 2 functions? 2 functions जो है, so all mapped to 1, suppose a b c d e, here 1 2, when all are mapped to 1, that is not onto, because here 2 will be free, when all are mapped to 2, 1 will be free. So this is why except those two all will be onto. So 2 power n minus 2 when n of b is 2, especially 2 my dear friends. Otherwise we are having lengthy formula that can be used. Okay, next. So these are in brief about permutations my dear friends. Permutation in the sense we've seen. Before I go to permutation, let me recall the important points. We start our discussion at fundamental counting principle of addition, multiplication, then box logic, then simple arrangements NPR. Whenever you are using NPR for arrangements, there are 3 important observations. Do remember, repetitions are not allowed. We are arranging in a line and all the things are dissimilar. Now the next model will be, if certain things are similar, how to handle, repetitions are allowed, how to handle, if not in a row, if it is in a circle, how to handle. These 3 things are the next upcoming model. After this my dear friends, we have seen problems based on divisibility, sum, as well as palindromes, specified order, and even we have seen the problem related to rank. These are the special models of permutations. With this we can almost handle all the models of permutations. Now coming to combinations my dear friends, in combinations you can see here, you see combination related basic points, selection of dissimilar things, geometrical applications, total number of combinations. After this we will also have divisions, distributions. Hello Kavya, yeah. राइट सर, हिंदी में बोलना है? अच्छा, जरूर बताता हिंदी में भी। ये देखिए कॉम्बिनेशन माने सिलेक्शन है। सो सिलेक्शन कैसे करना देखते हैं। सिलेक्शन माने क्या है, मैं अब पहले ही बताया था इस सेशन में। अगर देर आर 5 स्टूडेंट्स A B C D E, 3 स्टूडेंट्स को रो में अरेंज करना है तो उसका आंसर 5p3 होता है। जस्ट सेलेक्ट करना माने सबसेट बनाना, सो 5c3 होता है। 5c3 का कंप्यूटेशन आप जानते हैं, 5 से 3 नंबर्स यू राइट बैक बाई 3 फैक्टोरियल। 5c3 ऐसे कंप्यूट करते हैं। एक्चुअली NCR का फॉर्मूला होता है n फैक्टोरियल बाई n माइनस r फैक्टोरियल इंटू r फैक्टोरियल एंड NCN होता है 1। ओके, सो माय डियर फ्रेंड्स, अगर 20 स्टूडेंट्स है, हमें 3 स्टूडेंट्स को सेलेक्ट करना है 20c3 वेज। 10 बच्चे हैं, उनमें से 4 सेलेक्ट करना है 10c4 वेज। इतना ही बस। या सो देखिए, सो NCR फार्मूला हम जानते हैं n फैक्टोरियल बाई इसी NCR फार्मूला होता है n फैक्टोरियल बाई n minus r factorial into r factorial, and do remember NCR plus NCR plus 1. So this is going to be n plus 1 CR plus 1 माने 8c3 plus 8c4, n सेम होता है, r 1 मोर होता है, इसका आंसर 9c4 होता है बच्चों। ओके, इसके बाद अब देखिए, सो यहाँ पे सिंपल प्रॉब्लम दिया गया है, NCR इज इक्वल टू NCS होता है, तो either R इज इक्वल टू S और R प्लस S इज इक्वल टू N होता है। ये प्रॉब्लम में देखिए 15 सेम 3R इज इक्वल टू R प्लस 3 होता है, या नहीं तो 3R प्लस 3 इसका वैल्यू 15 होना चाहिए। माने 2R is equal to 3 is impossible because R is an integer। यहाँ पे क्या होता है, 4R is equal to 12, R is equal to 3 बोल सकते हैं हम, R वैल्यू 3 होता है। ये NCR में याद रखना N and R दोनों भी ये इंटीजर्स हैं। ये सिंप्लीफिकेशन आप आराम से कर सकते हैं। 14c4, अगर यहाँ पे आप सिग्मा लगाते हैं, J इज इक्वल टू 1 होता है 17c3, 2 होता है 16c3, देन 15c3, देन 14c3। अब देखिए 14c4 प्लस 14c3 कुल मिला के 15c4 होता है। इन दोनों का सम 15c4 होता है। 15c4 प्लस 15c3 16c4 होता है। 16c4 प्लस 16c3 17c4 होता है। इन दोनों का सम 18c4 होता है। सो इसका आंसर होता है 18c4। ओके, इसके बाद अब देखिए, ये सिंप्लीफिकेशन बेस्ड प्रॉब्लम्स है, आप आराम से कर सकते हैं, इसमें कुछ भी स्पेशलिटी नहीं है। ये देखिए, द ग्रुप कंटेन्स 6 men and 3 women। ये देखिए 6 men and 3 women है। A committee is to be formed with 5 people containing 3 men and 5 women। सो हमें ये पर्टिकुलर सेट से 5 स्टूडेंट को सेलेक्ट करना पड़ेगा। इन सेलेक्शन में 3 men होना चाहिए और 2 women होना चाहिए। सो 3 men को men से सेलेक्ट कीजिए 63 वेज, 2 women को women से सेलेक्ट कीजिए 3c2 वेज। हमें टोटल सिलेक्शन या दोनों भी सिलेक्शन करना चाहिए बाय फंडामेंटल काउंटिंग प्रिंसिपल ऑफ मल्टीप्लिकेशन, इसे प्रोडक्ट करना पड़ेगा। ओके, नेक्स्ट बच्चों, ये देखिए, यू सी इन अ चेस टूर्नामेंट वेयर पार्टिसिपेंट वर टू प्ले one game with another, 2 chess players fell ill having 3 games each. Then the total number of games played is 84. The number of participants at the beginning was, suppose dear student beginning में 8 players है, तो कैसा कर सकते हैं, you see 2 chess players fell ill having played 3 games each, माने 3 plus 3 6 games हो गए। Remaining क्या है, n minus 2 स्टूडेंट्स होते हैं। Whenever you select 2 games, 2 students out of them, there will be a game। सिलेक्शन है क्योंकि ए बी और बी ए दोनों में गेम एक ही काउंट किया जाता है, n-2 C2। एट टुगेदर इसका वैल्यू n84 आया है। सो इस सिंपल इक्वेशन से n वैल्यू हमें डेफिनेटली मिल जाता है। ओके, देखिए एक क्वेश्चन, the number of ways for a volleyball game, 6 can be chosen, selected out of 10 players so that 6 particular players are not included. A देखिए 6 can be, yeah, there are 6, the number of ways for a volleyball game 6 can be selected out of 10. A 10 से हम 6 members को select करना पड़ेगा. If no restriction, answer क्या है? 10 से 6 होता है. लेकिन यहाँ पे restriction है कि 2 particular players are always included. So अगर वो players को जरूर include करना है तो हमें और only 4 student को selection करना पड़ेगा from the remaining 8. माने 8C4 होता है. अगर क्वेश्चन कभी कभी ऐसा भी हो सकता है कि 2 particular players are not at all selected, माने 2 particular players not selected माने remaining 8 से हमें 6 को select करना पड़ेगा क्योंकि हमें 2 चाहिए. So देखिए direct without any restriction selection must include, must not include. अगर क्वेश्चन ऐसा भी हो सकता है कि एक particular student, एक particular player should not be included, one particular player will be included. जो include नहीं होना है उसे निकाल दो, तब हमारे पास 9 है, 9 से 6 सेलेक्ट करना पड़ेगा. एक प्लेयर को जरूर लेना पड़ेगा, वो पर्टिकुलर प्लेयर को ले लो तो रिमेनिंग 8 से हम 5 सेलेक्ट करना पड़ेगा. उस सिचुएशन में हमारा आंसर 8C5 होता है. ये देखिए पर्टिकुलर स्टूडेंट इज रिक्वायर्ड, नॉट रिक्वायर्ड, इसके बराबर हम सिलेक्शन आराम से कर सकते हैं. नेक्स्ट डियर स्टूडेंट, द नंबर ऑफ ऑल 3 एलिमेंट सबसेट्स विच कंटेन A3. हमें क्या है, इसमें से 3 एलिमेंट्स वाला सबसेट को सेलेक्ट करना पड़ता है. उसमें से A3 तो जरूर होना चाहिए. अगर A3 जरूर होना है तो रिमेनिंग n-1 एलिमेंट से 2 एलिमेंट्स को सेलेक्ट करो, n-1 C2 वेज, और 2 एलिमेंट्स और A3 को लेके कुल मिला के हमें 3 एलिमेंट के सबसेट मिलते हैं, है कि नहीं. देन इसके बाद a person has 5 friends, in how many ways can he invite them to a party. ये तो important conceptual question है. अब देखिए, a person has 5 friends A, B, C, D, E. In how many ways he can invite them. माने यहाँ पे एक पॉइंट हमें ऑब्जर्व करना है कि कितने फ्रेंड्स को इनवाइट करना है, ये तो स्पेसिफाई किया नहीं गया. माने अब ऐसा भी सोच सकते हैं, अगर 2 फ्रेंड्स को इनवाइट करना है तो उसका आंसर 5C2 होता है, 3 फ्रेंड्स को इनवाइट करना है तो 5C3 होता है, 4 5C4, ऑल 5C5, 1 5C1, नन ऑफ देम इवन. किसी को भी सेलेक्ट नहीं करना बोले तो 5C0 होता है. ओके, माने यहाँ पे कितने स्टूडेंट्स को सेलेक्ट करना है वो तो स्पेसिफाई नहीं हुआ, माने आपको वही एज्यूम करना पड़ेगा. ऑल द पॉसिबल नंबर ऑफ सेलेक्शंस आप फाइंड आउट करके सम करना पड़ता है, समझे. इसका आंसर होता है 2 पावर 5. इसे बोलते हैं टोटल नंबर ऑफ सेलेक्शंस बचे. नो, चिदविलास इज नॉट माई स्टूडेंट. यस, या ऑल इंडिया टॉपर Chidvilas, right? I never taught to him, right? But I have interacted after he got All India first rank. I have just interacted. Okay, fine. 2 power 5 is total number of things, right, my dear friends? Yeah. Then you can say the same question you can also answer like A may or may not be selected, right? 2 ways, B also, C also, D also, E also. You can write 2 is multiplied 5 times, the answer is 2 power 5, right? Yes, I know. Yeah, Chidvilas Reddy, Sri Chaitanya, All India first ranker. This year we got All India first rank in JEE Advanced, JEE Mains and NEET in a row, all first ranks. Yeah, right, dear students, this is all together 2 power 5. My dear friends, you see the simple point is a person has 5 friends. In how many ways you can select 2 of them? The answer is 5C2. In how many ways he can select is the question. If you didn't specify how many are to be selected, the total number of ways you have to write as 2 power 5. That is the major difference between these two, dear students. The next, you see, a team of 11, this is already, this concept is done. A team of 11 are to be chosen from the group consisting of 6 and 8 players respectively. Okay, the number of ways of selecting them so that each selection contains at least 4 players from first group. You see, there are 6 here and 8 here. Altogether, I have to select only 11 students, right? Next, my dear friends, the number of ways of selecting so that each selection contains at least 4 players from first group. Money, 4 players from first group. You can take 4 here, then you have to take, you can say 7. If you take 5 here, you have to take 6. If you take 6 here, you have to take 5, and you cannot go further here. Okay. So, 6C4 multiplied by 8C7 is the first combination, plus, because another combination होता है 6C5 multiplied by 8C6 plus 6C6 multiplied by 8C5. इन तीन को ऐड करना पड़ेगा, you will be getting the answer, right? The next, my dear friends, you see, this is another conceptual one. From the set of 10 identical balls, find the number of ways of selecting 3 balls. Please observe that 10 identical balls. अगर all the 10 balls dissimilar होते हैं तो 3 balls को 10C3 ways में select करते हैं. अगर आइडेंटिकल है 3 balls को सेलेक्ट करना है, यानी 3 इज फाइन, द आंसर इज ओनली 1 वे अगर आइडेंटिकल है तो, राइट? यहाँ पर भी यू सी द नंबर ऑफ 5 balls इफ ऑल आर डिसिमिलर बॉल्स 10C5. अगर ऑल आर आइडेंटिकल 5 balls को सेलेक्ट करना ओनली 1 वे होता है. और at least 1 ball. In how many ways we can select at least 1 ball means here total number of ways is 2 power 10. Not selecting any one is 1 way. So 2 power 10 minus 1, my dear friends. ये कब है? If balls are dissimilar. अगर identical है 10 balls को total number of ways of selection is 11 ways. You can take 1 ball, 2 ball, 3 balls, all balls or no ball. So total number of cases here you can say 10 ways, my dear friends. Total number of selections is here 11 ways, here 2 power 10. Please observe the difference between number of ways of selecting when the things are all balls are dissimilar, आंसर ये होते हैं, आइडेंटिकल तो आंसर ऐसा होता है. नेक्स्ट ये देखिए, the number of ways of selecting at least 1 letter from the letters of the word proportion. प्रपोर्शन देखिए, PRO, POR, TION, यह है प्रपोर्शन में लेटर्स. इसमें क्या है? 2 P's, 2 R's, 3 O's है. द नंबर ऑफ वेज एटलीस्ट 1 लेटर फ्रॉम द लेटर्स ऑफ द वर्ड प्रपोर्शन. वेज ऑफ सेलेक्टिंग एटलीस्ट 1 लेटर. टोटल नंबर ऑफ सेलेक्शंस क्या है? 2 P's है. P's can be selected in how many ways? You can write like, yeah, 3 ways, my dear friends. 3 ways. Because you can take 1 P or 2 P's or no P. R's also 3 ways. O's 4 ways because they are identical. You can take 1 or 2 or 3 or none. T 2 ways, I 2 ways, N 2 ways. You just multiply, you are going to get the answer. Bas. So total number of selections when certain things are identical. You see, because you see this case is all are dissimilar, this case is all are identical, this case is like some identical of one kind, some dissimilar. Okay, so in that case we need to select like this. The next, my dear friends, 10 straight lines in a plane are given, see 10 straight lines in a plane, no 2 of which are parallel and no 3 are concurrent. The points of intersection are joined, then the number of fresh lines formed. ये देखिए बच्चों, there are already 10 straight lines such that no 2 are parallel, no 3 are concurrent. So the total number of points of intersection will be out of n. Whenever you select 2 points, you will get a point of intersection. 10 lines are there, so 10C2, my dear friends, 55. There are 55 points of intersection. You see line 1, line 2, line 3, line 4, like this. So no 2 are parallel. In fact, my dear friends, I can say, yeah, in this way the question is given. Okay, suppose another one. So like this. So out of the 55, on every line, you see there are 10 lines. Suppose I have taken here 5 lines. On each line you can find 4 points of intersection. Here there are 55 points, of which on every line 9 points are collinear. So my dear friends, if you want new lines, he is asking the number of points of intersection are joined, then the number of fresh lines formed. Out of 55, whenever you select 2 points, you will get a line. But of these, if you have selected 2 points out of these 9, you won't get a fresh line, right? Here also 9C2 kind of, there are 10 such lines, my dear friends. 9C2 kind of, how many such lines? 10. This gives the answer, dear students. Okay. Next, my dear friends, you see the sides AB, BC, CA of triangle ABC, geometric applications we are talking about. You see 3, 4, 5 interior point respectively. So he has taken a triangle, dear friends. Here 3 points are taken, here 4 points are taken, here 5 points are taken. Now the number of triangles that can be formed using these points as vertices. You see, you have to select 1 point here and 1 point here and 1 point here. This is 5C1. You will get a triangle. Or else if I select 2 points here and 1 point here, then also suppose we get, you see the number of triangles that can be formed using, or else you see simply 3, 4, 5, altogether 12 points. Out of 12, whenever you select 3 points, you will get a triangle. But if the 3 are from these 3 or these 3, or if the 3 are from these 5, you won't get a triangle. So total number of selections minus 3 from these 3, 3 from these 4, 3 from these 5, you can subtract. Okay, rather counting all these cases, you can do like this. Next, my dear friends, in the same way, if there are P points in a space of which Q points are coplanar, then the number of planes formed. To form a plane, we require 3 points. Whenever 3 out of this P are selected, those many planes are possible. But if Q points of them are coplanar, from those Q, whenever you select 3, you will get the same plane. So I subtract this, but you will miss one plane. So 1 is added, since this is going to be the answer, right? The next, my dear friends, so all these questions are of geometry applications. We can say, yeah, so these are simple geometry applications. So I want to go with, you see, specific kind of, you see, even these problems are all geometric applications. You can try, you see, maximum number of points of intersection of 8 circles, my dear friends. If you take, you see, if you take 2 circles, 1 circle you will get 0 points, 2 circles you will get 2 maximum points of intersection. Third circle, apart from earlier, we got 2 plus 4, which is 6. And if you take the third circle, which cuts all the other 3. So friends, if you take 8 circles, 2 plus 4 plus 6 plus, like you can say, I mean to say, 8 plus how many terms? 10 plus 12 plus 14 you have to add. That is going to be, I mean to say, dear students, here you will get the number of circles, or else you can say out of 8, whenever you select 2 circles, you will get 2 points of intersection. This is going to be 8 into 7 by 2 into 2, my dear friends. Here also you can take 2 common, 1 to 7, sum of first 7 natural numbers, n into n plus 1 by 2. Both will give the same answer, dear friends. So geometric applications are simple. I mean to say, these points are already covered. So I want to go with, you see, distributions, especially distributions, and we can say, yeah, you see, division and distributions. Find the number of ways of dividing 12 dissimilar objects into, you see, 2 groups of 3 and 9 objects. You see, when these 3 and 9 are anyhow different numbers, the answer is actually 12C3. The answer comes like 12 factorial by 3 factorial into 9 factorial. Okay. Now 3 groups of 2, 3, 7. The answer will be 12 factorial by 2 factorial into 3 factorial into 7 factorial. Dividing. Okay. So 2 groups of 6, 6 each. Since both are equal, 12 factorial by 6 factorial into 6 factorial into 1 by 2 factorial we write, my dear friends. Okay. Suppose 2, 2, 3, 5, you will get 12 factorial by 2 factorial into 2 factorial into 3 into 5 factorial. Now you can write, there are 2 identical 1 by 2 factorial you will write, my dear friends. Then 2, 2, 2, 3, 3. You see, if 2, 2, 2, 3, 3 is the combination, 12 factorial by 2 factorial 3 times, 3 factorial 2 times, multiplied by, my dear friends, there are 5 by 3 factorial into 2 factorial. Like this, we will divide certain objects into groups. Okay. The next, my dear friends, division of dissimilar things into groups we have discussed. Now distribution. You see, the number of ways of distributing 12 dissimilar objects into boxes. Division is fine, then distribute. Just now we have seen division is 12 factorial by 3 factorial into 9 factorial. Now you are having 2 different groups. You have to arrange into 2 groups, which is 2 factorial. After division, you have to write the distribution. Here 2, 3, 7 you can write accordingly. Suppose 6, 6 in the sense 12 factorial by 6 factorial into 6 factorial into 1 by 2 factorial. This is what I say division. Even though you have divided into 2 equal groups, suppose 1 to 12 numbers, 1 to 6 one group, 7 to 12 other group, these are dissimilar items, you have to arrange between 2 groups into 2 factorial. Sometimes he will use the phrase like, in how many ways you can divide them between 2 persons. Divide them between 2 persons. So between 2 persons means dividing between 2 persons means distribution only. Do remember. Okay. Then next, my dear friends, similarly you can write this. We have written 12 factorial by 2 factorial cube into 3 factorial square into, this is 1 by 3 factorial into 2 factorial. You have got 5 objects here. They are dissimilar because suppose first 2 is like 1, 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can arrange into groups in 5 factorial ways. This is how we divide and distribute, my dear friends. The next I can say, yeah, division number of into 12 similar objects. The earlier case is they are dissimilar. Suppose 12 are, I say, similar. How will you divide, my dear friends? Divide into groups of 3 and 9. All are same. 3 and 9. Division is only one way. You just separate 3 objects. 3, 9. Which 3? There is no difference. Division is one way. 2, 3, 7 objects. Division is one way. 6, 6 one way. 2, 2, 3, 5. Division is one way. That's it, my dear friends. When the things are similar, identical, the division is very simple. Next, my dear friends, the number of ways of dividing 12 similar objects into two dissimilar groups. Are yaar, 12 similar, division is one way, that means 12 and 9, 3 and 9, but the boxes are dissimilar. Boxes are like A, B, so 3 goes into A, 9 into B, or this into A, this into B. So you can write into 2 factorial ways because boxes are dissimilar. Now 2, 3, 4, division is one way, distribution, these are 3 different numbers, so sizes are different, you will get 3 factorial. The next, my dear friends, 6 objects is, division is one way, but these 6 and these 6 are also identical now. So suppose dissimilar items 1 to 6, 7 to 12 are dissimilar, so 2 factorial. Even though boxes are dissimilar, the items are identical. 6 items of same color and same size, here 6. So 2 identical ways, you won't get 2 factorial. 2 factorial by 2 factorial you will get, my dear friends. Here also you will get division is one way and distribution, so 2 identical, 2 different for 4 boxes. 4 factorial by 2 factorial you will get. This is how we divide and distribute dissimilar objects into different boxes, similar objects into dissimilar boxes. Now, you see, my dear friends, number of ways of dividing 80 cards into 5 equal groups of 16 each. You see, 80 different cards there are, 5 equal groups of 16 each. So 16 factorial by same number, right? So 16 factorial 5 times, because the number is same, into 1 by 5 factorial you will get. So 80 factorial by 60 factorial power 5 into 1 by 5 factorial. The next, my dear friends, the number of ways can 5 things be divided between A and B. This phrase is important. Divide between A and B means distribute so that each receives at least one thing. So my dear friends, so you can also do like 5 dissimilar things, say A, B, C, D, E. So persons are A, B. That means we have to distribute these things into 2. You just, why don't you write number of onto functions? A can go to A to B, B also. You can write, my dear friends, 2 power 5, 32 minus, if all go to A, B won't receive anything, all go to B, A won't receive anything. These 2 things you have to subtract, so 30 is the answer. That is one important way. Next, my dear friends, these are all easy. You see this question, the number of ways of distributing n identical balls into r distinct boxes such that no box is empty. This is an important formula, I think you know. The number of ways of distributing n identical balls into r dissimilar boxes such that no box is empty. So my dear friends, you can see here like n identical balls into r boxes. So suppose you can treat like 10 identical balls into 4 boxes. So what we do is, my dear friends, on the ground you can put 3, 4, 5, 6, 7, 8, 9, 10. 4, 8, 9, 10. So these things are to be kept in 4 boxes, right, such that no box is empty, he said. Okay. Generally this is one case. Here you see in how many ways you can distribute, this is other case. In the first case what we can do is, my dear friends, you have suppose 4, 8, 9, 10. So you want to put in 4 boxes, so take 3 vertical lines. So 3 lines and 10 identical lines, you just arrange in a row. How many ways you can arrange? 13 factorial by 10 factorial into 3 factorial. Suppose one of the arrangements is this, this, this. So 2 balls are there before first row, we put 2 in the first box, 2 in the second box, 1 here, remaining 5 here. 2, 2, 1, 5 we put. Which 2 it doesn't matter because all the balls are identical. Suppose, my dear friends, You have got 2, 2 here, it is not there. That means 2, 0, 3, 5. Like this you will be getting all. This is nothing but, my dear friends, n plus r minus 1 c r minus 1. So n balls and r minus 1 vertical lines, n plus r minus 1 c r minus 1 is the formula. Do remember, my dear friends, n identical objects are to be arranged into r boxes. Boxes are dissimilar is the case. If no box is empty, for example, my dear friends, here the answer will be n minus 1 c r minus 1. The logic is simple. 10 are to be arranged into 4 in the sense, so no box is empty, there are 4 boxes, right? So 4 boxes, first you put one item in all the 4, you are left with 6. Now 6 are to be arranged into 4 such that you can put in any way now. So n plus r minus 1 c r minus 1, which is, you see, 9c3, which is n minus 1 c r minus 1 is also the same. So my dear friends, I mean to say here, the number of ways of distributing this, based on which we will be having, my dear friends, derangements is fine, then we will be having problems based on, really Raja, thank you, thank you very much. But it's a quick way, no? So we are going a bit fast, but its extension will be number of integral solutions. There we will be having n number of models. I will try to take one separate session for that because the time is up. So my dear friends, I have brought almost 90% of the permutations. Thank you very much. 90% of permutation combinations at almost in 90 minutes, right? So dear students, do remember one important point. Permutations wise number of concept model will be huge. Combination wise only 2-3 formulae, but we get huge number of applications. So dear students, just practice the problems, try to know the difference between model to model, especially concept to concept. Permutation combinations will be very easy. One important point that I want to say, my dear friends, you take any JEE advanced question, especially it is reachable. Advanced question from permutation combination, that question is not at all difficult. With this content you can definitely answer even advanced questions also, right dear students? That's all for the day. Stay tuned to Infinity Learn. We'll be in touch, we'll be discussing the further models in the upcoming classes, right? Thank you, take care, bye dear students, bye.